Hello, everyone. I hope this mic's working. I don't know, something's been weird about this. So, today I think we're going to be doing some Haskell. I've been really struggling. Like, I'll take some time in the beginning here, just free chat. I think I've been struggling to like kind of figure out what to stream. My life feels very unstructured right now. So, why am I so hot low? Mm. My life feels very unstructured right now. I'm like, don't really have a job. I quit the one I was doing. It was like a lot of AI work, and while some of it was interesting, most of it, like, either values wise or just the way it was like pushing for constant AI productivity, just like felt like, the fun of creation and the fun of programming wasn't there. There was a lot of bugs being created that took a long time to figure out, and I really guess I didn't enjoy working mostly in TypeScript. That felt rough. Um, so yeah, I was out there for work, and then I was like, yeah, this isn't working. I actually went there. It was supposed to be like kind of a productivity session, and then it was just like, no, it wasn't happening. So we kind of decided that we wouldn't continue working together. And they were really nice about it. It was fine. Um, but what that means is like, sorry, I'm kind of using you guys as like, hi, good to see you. I never know how to say your name. Like in French, pois means peas. So I always see pois nada. Or I guess it could mean like, no, it just means peas, like green peas. Anyway, good to see you. I haven't streamed in a while. I was just saying, like, I quit my job. I have a small contract, but I'm kind of have had a hard time getting motivated to work on that because it's so vague and amorphous, but I really should work on it. I've been spending a lot of time like just doing other fun stuff that has nothing to do with tech, like singing in choir, classical singing, stuff like that. That's been a lot of fun, but doing a lot less tech work. But I want to get back into it. I thought at first I was just depressed, but I'm not depressed because like I do other things. I go out, I have fun with friends. I like started like playing chess more. I do the singing thing. I'm like learning songs and stuff like that. So like I'm not it's not like depression where it affects everything. And I thought maybe it's burnout. Like maybe I'm burnt out and I just don't want to do things. And then yesterday I thought, "Oh, well, my psychiatrist let me control like how much meds I take for ADHD, so I tried taking a little bit more. I just had so much more motivation to do stuff. Today I didn't take any because I felt a little wired yesterday, so I thought I would give my body a rest today. So I thought maybe it's a balance of like my meds. I don't think it's burnout. I don't think I'm burnt out per se. I think I still find tech interesting. It's just that like with singing, there's such a clear like motivation. I sing, I practice singing, I get better at it. There's technical aspects for the physicality, but there's also technical aspects for like reading sheet music and things like that. And then you get better at it. Then you like go to a rehearsal and I mean, I hate it to say it this way, but you kind of are showing that you can do it, and it feels good. Like you're like, hey, look, I can do this. And you get a dopamine hit from that. And then you have a concert. Like I'm helping out this choir and they're having a concert in March, and like I'm thinking about that, and I'm like, okay, we're gonna sing well for that. I want to do it. So like, there's all this like connection in terms of like why you do something and what the results you get out of it. And with some of the tech stuff, like I really just enjoy futzing around and learning stuff. Hey Findus, good to see you. There was so much snow. But it was fun. It was so fun. It's not snowing now. It's much milder, and I think the US has a lot of snow now. My parents told me that they have snow outside their building. Oh, I should put on chat here. I can do this. Um so yeah, what was I saying? Yeah, I just don't know with the tech, like, what am I trying to do? I gave two talks recently. They're both on YouTube, not in my account, but you may have seen it. One was at Goatmeyer where I talked about nerves and embedded systems programming. That was so much fun. And then I talked about, hey Chris. And then I did another talk at CodeBeam EU where we talked about like how to get ahead as a tech person in at work, like what I've done. And that was fun. And this next one, I have an Elixir Conf coming up. Let me see what it is. It's Elixir Conf EU in Malaga, Spain. Let's see if we can find it. Um, and I'm going to be talking about building game servers, like, sort of like MMORPG game servers, um, using Elixir. So that should be fun. Here, I search for myself. Um, so here's Elixir Conf, and they cost so much money. It's like if I don't talk to at these things, I can't afford it. Like early bird conference tickets, $539. It's kind of pricey, right? I mean, I'm here to like, yeah, go to this, but I know that I don't always have a lot of money for this. Um, but anyway, where am I? I'm here somewhere. What a terrible picture. So it's about writing game servers. I did some of this before. I started a company that was like an MMORPG game server before. And I'm going to make a roguelike game running in live view and then basically turn it into a multiplayer game and talk about how Elixir and, actor model is really good for this. So that should be fun. Um, we'll see how that goes, but I really have to start working on that soon. And I want them to like play while I'm doing the demo. I'll be like, I think I'm going to have PRs where we're like, okay, now we're going to add this part where it's like we have login, right? And and then everyone has a QR code and they can log in and we can see that. We'll like, merge the PR and run the server. And then we'll merge in like users maybe chatting and users moving, just like, and we'll look at the PR. I hope it's just not too big that it's hard to do in time. But it's going to be a 40-minute talk, so I think I will have enough time to do all of that. We'll see. Um but I think it'll be fun. And what I'm also hoping for is so I built my first game server that I built was in Java. And that was sort of a mess because, in Java you just do usual thread stuff and you have mutexes everywhere. And then I built one in Rust. And that was really cool when you're just dealing with Rust, but then once you have mutexes and all those arcs, like they're just all the automatic reference counting and stuff like that, it just becomes so messy and you feel like you're no longer coding in Rust anymore. And Elixir kind of handles a lot of that. I think the ideal solution is actually like a mix of using something like Elixir and calling Rustler like the NIF, the native inline function or whatever it's called, native interface for functions. What is it? And and that's probably a really good way to get the performance you need where you need it, but using Elixir for its concurrency model. Anyway, but my hope is that like the game server itself can become an open source project that I can continue to build and have like games actually use it. It doesn't have to be an MMORPG. Like a lot of times you just want a server for your FPS game or whatever, your MOBA. I don't know. We'll have to kind of figure out how specialized it is, because the performance characteristics for each one is very different. For an MMORPG, like the movement, you know, prediction and stuff like that has to be good. Um, but I don't know. I never built an FPS version of it. I don't think it would change things too much. But server resolution for combat in an MMORPG, like you have a combat server thread that's running and it's like it's doing the things you expect. It's doing there's an AI that's running. When I say AI, this is like old school AI, mob AI, right? Where it's like, does it aggro you? And if it aggroes you, what attack does it do? And stuff like that, right? And it's running all of that in the combat server and it's handling these sort of like ticks. But in an FPS, like when you shoot, you got to do like, the ray casting sort of thing and all of that. And it has to be really accurate. So I just worry that like one server solution for all, I'm not sure if it really works. So this would be kind of more, I think I would first think of the use case as an open world sort of exploration game. You want to build a Zelda, you want to build like all of these co-op games that are out now. Like, I don't know if you guys have seen like Enshrouded or like Tale and Tavern or whatever they're called. They're all kind of that. Did you code in Fourth? No, I made an architecture in university with a microcontroller instruction set and everything that was basically stack based, and it was heavily inspired from Fourth. I really like it. I do want to play with Fourth one day, but I don't see it as like, like right now I want to my main goal is to get through Haskell. um I've tried several times to get through Haskell, but I feel like there are some programming language, you know, concepts in there that I don't know yet and that I really really like practice with. But Fourth, yeah, I mean, I've looked at it, but I've never programmed in it. Like, I guess technically I even got paid as a Fortran programmer once for my physics lab in university, and for an actual research company doing like cancer research. I did some Fortran, not Fort yeah, Fortran programming, but I would definitely not consider myself a Fortran programmer. I guess you could be, the whole division between like professional and amateur is just so weird, right? Because you could say I was a professional Fortran programmer, but I suck at Fortran programming, Like, you would not want me doing any code for that. Um, you could learn what I know in Fortran in like, 30 minutes. Like, I don't remember anything. I just remember like all the variable names had to be really limited. And I was basically programming with like physicists, so like they don't comment their code whatsoever. It was terrible. Anyway, yeah, so like the amateur professional thing is so weird in life because like I feel like I'm an amateur in so many things. But what does that mean? And I can even get paid for doing some of those things. Does that make me a professional? Like it's such a bullshit thing that we put so much like importance to. We place so much importance to this divide. I can get I'm kind of good at convincing people to pay me to do things I don't really know how to do that well. And like, so will that make me a professional? So weird. Anyway, so Yeah, this whole thing is about me having been living a very unstructured life without a job. Like, here's the thing, like, previously in life, I've taken 2 years off of work. That's what the most, before this last job, I wasn't working for 2 years, right? I was still doing tech stuff. Like, I still enjoy doing tech projects all the time. So I'm always coding. It's not like I stopped tech and I just, whatever. Um, but I didn't work. I wasn't getting paid for 2 years. And then I got this job. I was so scared that like not having work, everyone's like, "Oh, your CV, you have a gap or whatever. It's so bad for you." I was getting so scared of like all the conventional things people say, but like it never hits me like I found a job easily. A friend of mine wanted to hire me. Um and it was like doing things I didn't know how to do. Like I just said, like it was mainly programming in TypeScript and I never programmed in TypeScript. Um And before that, I have taken a whole year off before that too. And I had the same fear like, am I irrelevant now? Has the world moved over to new things? And like, yeah, this last time was weird because the whole company was all coding with like Claude for everything. It felt like tremendous amount of vibe coding. I don't think that's all companies, but like, yeah, they were definitely doing the trend there. And they were like, why are you using Helix editor? Use cursor. And I'm like, I don't know. I want to try to fit in and like be like, yeah, cursor, but like, I'm not really into the whole whatever, that hype cycle. So right now in my life, I'm trying to figure out like how how much do I need to work? What kind of work should I be doing? And how do I spend my time like literally right now? Like if I stream, I kind of want to stream stuff that not only helps you guys, perhaps, even if it's just motivation, but it also helps me because I'm learning stuff that I may use someday, right? But like Haskell, how am I going to use that, right? I don't know. I think a lot of things that I'm interested in, they help me in some very side way somehow, like just knowing something, or maybe it'll make me a better programmer. Like it won't help me, but it'll help me. So, but in my life I've never really like thought about what I'm doing too much. I just kind of like, here's my interest and I'm going to go follow it. And it's worked out so far, but so many of my programmer friends are like, they're saying they can't find jobs. They can't, it's like really difficult out there, and it just makes me kind of scared. Like, okay, does that mean like now I have to really try? Or do I just continue living my random happy go lucky life and just see what happens? So that's where I'm at. All right, let us try to do something. Self-taught certification 30 days ago. What's the certification in? What did you get the certification in? Oh, you know what? Let's do some chess puzzles first. Can I make this bigger? All right, let's see here. So this puzzle here, I'm pretty bad, so don't reverse engineering. What does that mean? Tell me more. All right, it's black's turn. Looks like a checkmating thing. I'm not that good, so don't expect much from my chess. Um We can go here, and if we go here, looks like they can't take because there's the bishop. Nothing. Can they block it? This guy can't block it. That guy can't block it. This guy can't block it. Yeah, so this is the move. All right. White. So we have these squares from the knight. We have a check here. So if I check here, he can take with the bishop. Oh, but even more directly, the queen can take here, and nothing can stop the queen. So let's do that. Analyze malwares. So what are you looking at when you look at the malwares? Are you looking at like the network traffic? Are you looking at the system? Are you looking at what operations it's taking in the system? Like what system calls it's making? What are you looking at? All right, checkmate for black. What checks do we have? We have no direct. We have this as a check, and we have this as a check. So if I take this, he can go here. And then that isn't great for me. I don't have a great follow-up for that. So we don't do that. And then if I go here, he can't take back. He can't move up. He has to move here. Right? No, he can't move there. He's screwed. All right. We reached stone 12. Maybe we play a quick game. I don't like playing on chess.com. So let's play a quick game on Lee Chess. Does it fit on the screen? It looks like it fits on the screen. We'll play Scandinavian. They take, we take. We go off to the side. Hmm. Let's get our knight out. Static and dynamic behaviors. Oh. So this guy is pinning my queen. If he comes out, right now he can't do much, but I will give my queen a way out this way and also block his knight from going in these two ways. But it lets my queen go here. All right, now he's come out to give my queen trouble. So I'm going to bring my queen back. Maybe we go here and we threaten this guy here. I'm the person who's always down on time. It's kind of ridiculous. Do I want to take with this pawn or this pawn? Kind of like this pawn because I now have this file here open for my rook, but it means I should probably castle the other way. So let us bring our knight out. That's going to block the bishop. So let's move our bishop out first. We try to find indicators like IP hard-coded keys to detect them. Static and dynamic behaviors. But how do you see the static behaviors? Is it like you're looking at the malware code? Like, what does that mean? Okay, now they're attacking here. Good stuff. That's fine. We will move out over here. And then we'll castle long. Okay, he wants to come here. That's all right with me if he does that. All right, what more do I need to do here? This guy's still attacking here. Maybe this guy should go here. And then he's forced to... He doesn't have a good place to go, right? He'll probably go here. Just take. He seems kind of aggressive. Ah, you disassemble them. Wow. When you disassemble them, what language does it disassemble into? Do you actually look at the, like, are you looking at assembly code or are you looking at, does it turn it into C? Also, they are obfuscated. We try to decrypt them. I have like no plans here right now. This pawn is blocking my knight quite a bit. And this pawn is sort of like stuck. This pawn, I mean, my rook is kind of stuck because it's guarding this, you know? Um, but if I move my, yeah, but I can block, this guy's blocked, but I can like push and then this guy is no longer blocked and it limits the bishop. So maybe this is a good move and it frees up my knight. So that seems kind of nice. So now this guy is blocked and my knight can move here. And that's not a bad square. In fact, he might want to go here. Oh, he's pushing. Wants to get to my queen. I can always move down though. Or at this point we can like move up. I mean, really this is not a bad square for my queen anyway because it's going to be attacking here, right? But now we can put pressure on this pawn by, well, let's continue to develop by moving this guy. And if he pushes here, Oh, wait, what if he goes here? That's okay. Then we just take. So if he if he pushes here, then we go here. Yeah, that's all right. We might push here. Let's see if he takes. No, not really good for me. What if we. Interesting. So he's targeting this pawn, which is a good move, actually. I can block that by moving here. So what is like what instruction set are you looking at? Is that basically x86 or ARM or both? Let's see, what would I do if I were this guy? I might start pushing down here. I might engage my rook. The queen's not out. Where can it go? Here? There's so many places. There's so much they can still do. They can like move their rook out to get it more active. This is not a bad move because then it targets this pawn also. And if they do that, what do I do? I might. Oh, interesting. They're kind of trying to screw up my. They're doing a good job here, huh? I think I take. If I wait for them to take, then my queen comes out. Then they can. Maybe they can harass my queen. Not that great. The queen's still protecting this guy. Yeah, I think that's okay. I'll just wait. So what I'll do is where can I start? Guess I should move this guy out here to make him a little bit more active. Usually it's 32 or 64 bits. But that's x86, you mean? Why would he? Oh, because of the. Oh, shit! I didn't see this. I lost my queen, guys. Fuck me. This is why I knew it was a bad. It felt bad, but fuck me, you know? God damn. Um, let's think this through. Yeah, that's it. This game is over. Oh, now I'm just so fucked. Uh, no, well, this is why you play. You got to be bad and then you get better, right? Just like programming. It's so hard. And this is like one of the things in life, like learning a language. I speak French, and you have to be okay like not speaking well at first, making mistakes. You have to be okay when programming, not knowing what the fuck you're doing. But like school and everything, social life, we're all so like taught to never make a mistake. So it feels so bad. And I played chess before and I just felt so bad. It was like such a big thing. Even playing like PvP games like Overwatch or League of Legends, like you just feel so shit when you lose, you know? Yeah, I read the rules for Go like maybe like 3 days ago for the first time. So I think just from a rules perspective, I kind of get it. It's like a game of surrounding things. But is it better to take here or is it better to do this? If I do this, there's no follow-up, but with the knight, if I take with the knight, there's not much of a follow-up either. Except this diagonal becomes free. So maybe I do this and we'll see what happens. Ay, ay, ay. Because now we're protecting this piece and we're attacking this guy. He wants to. He's. What is he doing? Protecting this rook. That's what he's doing. Um. Maybe I should attack the queen. Doesn't have that many places to go to. Now he has to move the queen, and maybe that means I can take the. Maybe that means I can take the rook, right? Because he can't stay on this diagonal. Yeah, which means I can take the rook, but he'll get my knight. Still all right. I mean, it's now I'm only down 4 points. I made some progress. Where's he going? He's attacking this piece, which is not defended. And I could defend it with either, or I can attack something. Let's see. If I go here, let's go here. Because then I'm defending this piece, and maybe I should fuck. um, he's threatening this piece. And the only thing that can really save that piece is this. Let me move up and then try to push. But that's not going to go too well because he'll move this guy out. Yeah, there's no way. Let's at least try an attempt here where we go and get the if he tries to do perpetual check, I'm okay with the draw. Damn it, that was stupid of me. Now I'm checkmated for sure. Like he can like get me in this one little narrow thing. Well, he can't go there. I guess I would just go here. No, that's better, yeah. If I go here, then he's gonna go here. And then it's over. Yeah. I don't think I have any other choice though. So I think he's won. Well, there we go. Game over. Play new game. No, we're done. My goal right now is to play one game of chess a day. Because if I don't play every day, I start feeling bad when I lose. But if I'm used to like basically losing once a day or whatever, then it's okay, you know? And my rating's not too bad. I just started. Where does it show you your like wins and losses? So I'm like 5-5. I think it's kind of like normal, right? Anyway, so we do some chess puzzles every day and then we do okay, so here's the thing guys. I want to learn Haskell. I've really struggled with this, like a lot, because I tried learning from this before, the Learn You a Haskell for Great Good. Let's make this normal size again. What I have, like, I had terminal here. Oh, we're like 120%. Why is it so, like, small? Maybe this is stupid. Anyway, let me make this a little bit. That too small to read? Anyway, actually the thing should be to the left and the terminal should be this way because I think we're going to look more here and the terminal is going to be smaller, right? Some people are sticklers for exactly right stuff, but I just couldn't care less. All right, so I tried learning, but like this book wasn't that great to like I think I got to where did I get to? Oh, modules. I got to 7. Wow, that was pretty far. And then it was just like, look at this, look at this, like, it was just like a whole bunch of like functions. And I was like, am I supposed to memorize all this? How do I, whatever. And I just gave up because look how long this chapter is. And it's just like library functions. But I think the idea is like I should just skim it and then continue. So what I'm thinking is, and then I got this other book, Haskell, Programming Haskell by First Principles. It's an awesome book, and I made some YouTube videos with like Lambda calculus. I would love to learn it with that, but it's not public domain text, so I can't share it with you, which means I'd have to learn it on my own and maybe do the exercises with you. But I suck at learning alone now. Like, I'd have to body double with somebody or go to library or something with my laptop and learn, and I just don't feel like doing that. So what I think I'll do is I will just use this resource. We're going to skip chapter 7, sort of. We're going to skim it, and we're just going to try to get as good as Haskell as we can from this book, and I think it's going to be possible. So, that's my plan right now. But I'm going to take a quick break to make tea. And yeah, I'm going to make some tea. Let's change the title here, Haskell Stuff. And I'll be right back. I'll be right back. I was making funny jokes and everything. So, it's time to start out. We're going to crack your eggs now. We've read a lot about being Haskell programmers and what they're like, and they're these magical things. But like, I uh, hey Charlie, when I kick them, I kind of put them in the block list on Restream, but not on Twitch. So I'm guessing it just stays there on your Twitch chat history, right? That's so lame. Ugh. I wish Restream had some kind of. I guess I need some kind of bot thing or something that gets rid of whatever. How are you, Charlie? So we're cracking some eggs today, Charlie. There's like we're gonna start learning Haskell again and again. This is like the third time. And like just like most times when you crack eggs, you gotta like come out and realize that you are a Haskell programmer. You had things that made you think, like um, you were maybe interested or curious about Haskell, but now you'll really do it. Let's see, banned list. I just have removed the space as a banned word. You know what? I've never really played Elder Scrolls. I played what's that other one? It starts with Ob. Ob? It's not Obsidian. Um Oblivion. That's what it's called. Oblivion. Yes. And I don't know if it's the same world. Wait, is Oblivion Elder Scrolls? It's just the name of Elder Scrolls 4? I'm so confused. But whatever that. Oh shit. I've been telling people I never played it. I played Elder Scrolls Online and I played Oblivion, and I really enjoyed Oblivion, but then I played like some Elder Scrolls after Oblivion, and it just felt so like open world, like I had no point, whereas Oblivion felt like way more story rich. So I enjoyed that. Whereas like oh yeah, Skyrim, that's what it was, right? Is Skyrim Elder Scrolls just like Elder Scrolls 5? I don't know this whole lore thing. Ah, shit. Is there an old Elder Scrolls 6? So, yeah, Skyrim was just kind of like too big for my little brain to wrap itself around. Ah, it's like GTA. It's just never going to happen. All right, so you launched GHCI, Glasgow, Haskell, maybe compiler, interactive, I'm guessing. And then we can do arithmetic, 12 plus 10 or 19, whatever. And I think that number is right, right? So nothing too fancy here. One thing to note is like if we do something like this, where you give it two integers, it actually returns a floating point number. So that's interesting. It has parentheses stuff. Yeah, we don't need we don't need to test that. Oh, this is a really weird thing. Like if you want to multiply a negative number, let's not just copy what the book says. 10 times negative 1, right? This should give you negative 10. But it says, "Hey, I can't like parse this." And that's because it thinks this is a function operator, the negative sign. So we have to put parentheses around it, and now it realizes it's a negative 1. Oh, hey there. I never know how to say your name either. Mid Hughes. Mid Hughes? Hi. All right. Where are we? All right, so now we know how to deal with negative numbers. The same thing goes with like, you know, other operators. We can't do that. Anytime we have negative numbers, we need to put them in parentheses. Okay, so we also have logical operators. We will probably remember this, right? I mean, like, it's one of those things you have to remember for every language. Like, what do they use? So we'll probably remember this. The not is interesting. It's just the word not. It's not like that. So we just have to remember that we use the word not. Equality. Ah, yeah, the unequal sign isn't bang equals. You don't do like 2 is not equal to 2. You have to do slash, and then that says false. 2 is not equal to 3. True. And it works for strings also. But we can't mix things. Hello is not equal to 3. And it's like, hey, these types don't work. The same way I don't think we can do something like hello plus 3. So Haskell is a very strongly typed language, and it won't let you get away with all of that, which I think Python lets you do. I don't know. I don't code in Python, but I hear it's very flexible, so I imagine it does. Okay, I don't think this is all that interesting. Functions are usually prefixed, meaning that like we call the function in the beginning of before the arguments to the function. So this command, this function successor takes in something like the number 10 and it'll give us 11. Um and it'll just basically add 1 to it. And here again, we see we can't give it a negative number, but when we put it in parentheses, we can. And I think what they're basically saying is, yeah, you don't do like 10 sucks because the function comes in first, right? So we learned about successor, and then there's another function min that takes in 2 parameters. If we just give it 1, it's not happy, but if we give it 2, the minimum is 10. We switch that around, it still gives us 10. So it's going to give us the smaller of the 2, and max will do something similar. And I don't know. This can take in strings also. Can I do this? Max is, this is info, max. It takes in an ordinal, which I guess is something that can be ordered. Type ordinal. It takes in anything and returns a constraint. Wow, okay, we're going to have to learn how this works. But here I can see that it takes in another A and returns an A. So these are the first 2 parameters, and this is the return value. We'll learn more about that later. Division takes 2 integers and does integral division between them. So it's basically unlike the slash that does 92 divided by 10, gives us a floating point. We can do div 92 10, and it just gives us 9 and drops the 2. Now, we also learn that we can, instead of doing prefix, whatever notation, we can give it infix by doing, putting backtick around the function name. So it's basically just saying, "Hey, I'm using infix notation, so my two arguments are going to be to the left and right of me instead of following me." And that's what that means there. We can do the same thing with max, like I assume the max between why can't I type anymore? Between 20 and 1 is going to be 20, right? So that's what that means. Normally, in a lot of languages, we use parentheses, but in Haskell, we don't. Well, we do use them, but we use them to group things together, not because it's giving it, it's not parsing it to say these are the arguments to a function. All right. I feel like I'm getting to know this book. This time, I really hope we can get through this book. I hope so. Baby's first function. Okay, since we're out of our egg now, we cracked our egg and now we're like actually admitting we're Haskell programmers, we're going to make our first function. So it's going to take in um, an argument and it's going to just double it. So let's try that now. Is it HS, I think, for Haskell? I think so. And then we're going to make a function double me, x is equal to x plus x. And we'll save this. I forgot how to use Helix. It's so embarrassing when your memory's just so bad. All right. Now we're going to run it. Do we think we can just give it like this? Oh, we can. Now we can do double me 10 and we get back 20. Isn't that awesome? We can also do :L and the name of the file. And it loads it again. And we can give it double me a floating point number, and it gives us the correct answer too. All right, let's make a function that takes two numbers and multiplies each by 2, then adds them together. They call it double us. So it takes in two parameters, it said? Yeah, so x and y. Trying not to look while I program, and I think this is how, this is how I learn. I don't know how you learn, but if you're struggling to learn things, try to like not look at the example and just try to like code it. Try to understand what they're doing. So they said double each parameter. So literally I should be able to do double me x and then add each one. Double me y. Right? And now we do load first and we do double us. Let's do 2 and 3. So we doubled 2, that gives us 4, and then the other one is 6. 4 plus 6 is 10. So we have the right answer, right? So that worked. They actually did it using that one, but we tried to use the functions we make because we're functional programmers. Here it is. They did it like we did. What is this saying? I don't understand. Oh, they're just saying like, yeah, if you use double me, then if you change double me, then uh double us will automatically change. Yeah, I get it. That's why you should reuse functions. Functions in Haskell don't have to be in any particular order, so we can first define, basically we can start with double us and then do double me. Now we're going to make a function that multiplies a number by 2, but only if that number is smaller than or equal to 100, because numbers bigger than 100 are big enough as it is. All right, so we see there's going to be an if and then. Let's not look and try to code this. Double, what do they call it? Double small. So we take in an x and we say if x is less than 100, I don't remember if they said, maybe there's like a less than or equal to here, I don't know. If x is less than 100, then we return, then we double it. And then we have otherwise, we just return the number, right? Let's see how it, does that look right? Yeah. Oh, oh, they just did it the other way around. If it's greater than 100, are big enough as it is. So if it's 100, we just return. If a number is smaller than or equal to 100, we double it. Oh, so it's smaller than or equal to. Okay, that's what it is. Double small. If it's 100, then we still double it. But if it's 101, we just return 101. All right, so that's what the if statement looks like. Um, Nothing too special here. Double it and give it to the next person. No, I'm just gonna take it. I just take it. The answer is always take it. No, seriously, like if someone's like, hey, we've been doing this, we started at $1 or something, or €1, and we kept doubling. At what point would you be like, nah, give it to me? Obviously, like, if it's small change, I'll take €1. Seriously, right? If you could get injected, like vaccines, you can get like 4G or whatever, 5G. Like, if there was an injection that just uploaded to you how to speak a language perfectly, right? Like, whatever language it is. It could be programming, it could be like a spoken language. And then you would sound just like a native speaker, right? You get to pick like where, what accent. What language would you pick? The 5G vaccine. Oh my God. I know, right? The only problem is if you got a 5G vaccine, they can hack into you. Oh, that's so sad. I I like asking these questions, but I never have the answer for myself. Like part of me thinks like I should learn Chinese because they're a world power and it's such a hard language to learn. Like probably the two hardest languages for me to learn would be Chinese and Arabic, right? Just because they're so different, they have a different like system for writing. So just like it's almost like It's like girl math with shopping. It's like I save so much time. How can I not do it, right? But it's not like I would probably really use Arabic that much. The language that I really would just like love to like have fun, to speak is like Icelandic or something like that. But who the hell speaks Icelandic except, a small handful of people? And then like they all speak perfect English also, right? Japanese is a good one, especially since my girlfriend wants to move to Japan. Like she's seriously looking, and if I move there, like I'm in a Japanese choir. I sing Japanese songs. Charlie, you've been at a concert, right? You've seen it. Like we sing Japanese. And like I have no idea. Like half the people there are Japanese and the other half like no Japanese. And I'm the only one there that has no interest learning Japanese, and I don't ever know what we're singing. She's like, how come you guys are singing this way? It's a song about love. I'm like, I didn't know it was a song about love. I had no idea. No idea. So, Japanese is high up there, but I don't know. It's not like it'd be kind of useful. The nice thing about Japanese is Japanese people do not speak English well. If you're talking about just like languages where like you could actually get use out of it, maybe Japanese people do not speak English well. Like German, Scandinavian languages, Dutch, they don't make sense to learn because so many of the locals speak English. Of those, Germans have the strongest accent. But yeah, so Germans speak English. They're better than French in terms of speaking English, but like they got strong accents. Whereas like Dutch people, you and like Danes and Swedes, like they don't you can't really hear their accent that much. You can understand what they're saying pretty well. When I went to Hanover, which I told you about, Charlie, like we had a meeting and it was like with German people, and I was like, "Wow, okay, this is strong." What is this doing here? Oh, it's what are these guys called? Tunikis? It's the beavers with the big balls. That's how I think about them. You know what I'm talking about? Tanuki. I think it's called tanuki, no? But it looks like Mr. Nook from Animal Crossing to me. And in the back, I guess that's his tail. Tanuki, yeah. Oh, I never made that connection. If we wanted to add 1 to every number that's produced in our previous function, we could have written its body like this. Yeah, who cares? Okay, and they're just telling us here that we can use this little tick, kind of like in math, you have prime. This is kind of like how they do it. All right, so here we're assigning a string to a variable. Some string is equal to hello world. Now if I type some string, we get back hello world. I wouldn't be surprised if there was like a length function. Let's see. There you go. Look at that. 11. Um, I'm not going to read. We'll do ADHD and skip it. Like raccoons, but not. But come on. Don't they have big balls? They're like literally like when I went to Japan, I was so surprised that like they actually have statues of these animals. It's real. They have statues with the big balls. This is why Japanese manga all that stuff has weird shit. Like it just the whole culture. If you're Japanese, I'm sorry, but it's weird. Unless there's literally an animal where their balls are like bigger than they are or half their size. Maybe those aren't balls. Maybe they're like just they just look like it or in the same place. Float in the sky on their balls. I thought I had a memory of that, but all right. Lists. Look, we can do lists in Haskell, but they have to be homogeneous, meaning we cannot mix shit up. We can do this, but we can't do this because that is a list of numbers and we tried to add a string inside of it. That doesn't happen. So a list just means it's ordered and it has elements that are separated by commas. And you can see they don't have to be unique elements at all, right? They can just be any elements. They just all have to be the same thing. So we can also do hello world and whatever, and that's okay. But as soon as we start adding different things in here, it complains. And yeah, they've added it to a variable. They assigned a variable, but and we also learned here as a side effect, we learned that characters are in single quotes, and then strings are basically a list of characters, um, which means, right, so if I do hi, that just turns into a string hi. I wonder if there's a function first. Nope. Car, head, yeah, head, hi. So this is saying head is taking the first element of a list, and H happens to be the first element, so it returns H. This is an annoying thing. I don't know. Maybe I need to. Oh, it's just telling me not to use this. Whatever. We're kind of going slow, but what I was asking, I don't know why I asked about the injection, but I just thought it was funny to kind of put it that way. It's kind of like Matrix, you kind of upload stuff, but injections seem kind of nefarious, right? Like, what would you want in an injection? If it wasn't like learning languages, would you want like what other things would you want there? I was posing it like what if you got an injection and it gave you like a mental disorder? Which one would you take? I think I was like, would you rather have ADHD or be autistic or whatever? But that's not really nice. The thing I know I definitely don't want is depression. I think I think chronic depression would be really tough. Well, I have ADHD, I'm autistic, but like I'd much rather have what I have than like have chronic depression. That must be really hard. I also think like bipolar must be really difficult. I have DID and I was asking my girlfriend, yeah, if you could be autistic or have DID, which one would you choose? And she said autistic, I think. And I agree. Like I think DID is just so weird. I still gaslight myself thinking I don't have it. It would change. Sorry. So Charlie, stop it. Don't make me laugh at that. Oh my god. All right. So double it. Oh my god, can you imagine? It's like that game where you have like a hot potato and it blows up at some point. Seriously, I'm the person who chooses like without thinking, right? So if we go to a restaurant and you ever get those menus that have like 100 things on it? When that's overwhelming for me, I just choose. I'm just like, look, scan keyword, that one, I like it. I'm gonna go for it. And if it sucks, well, it's an experience. But my girlfriend's like, okay, now I have to read all of them. So I'm sitting there with my ADHD gremlin mind, like, like, oh my God, how long is this going to take? And just waiting as, like, the waiter goes by 5 times. I'm hungry. Anyway, it's just like, we're all different. Okay, so we have lists here. We learn how to combine lists. So if we have a list of just one element, and realize you can have a list of no elements, right? And we can combine it with a list of two elements, and obviously it kind of looks like the list with two elements. But if this one had a 3, then we have the 3, 1, 2. It puts them together. It's just concatenating them. So that's nothing too special. And we can have lists within lists. So here is a list of one element. Here's a list of two elements. So here's a list that contains two lists, right? And now I'm going to add another list of lists to it. So you see here, this one was in the first list of lists, and it added this 3, 1 to it, right? You have to think of each one of these are elements of this list. So the concatenation operator can take this element, and this element and join them all together in a single list. Maybe that's whatever, right? Um, yeah. Um, and you can add words, a list of words, which is a list of lists, remember, and concatenate that. Try this. And now we have A, B, C, D, E, F. Try this. Hopefully that makes sense. If anyone has questions, just stop me. So, it's saying don't use this a lot if you have long strings because it basically has to iterate through, um, I think this first list so that it can place this at the end. So if you do it a lot, it's kind of expensive. But putting something in the beginning of a list, like imagine if you're doing this like, um, yourself algorithmically, I give you one list and I say, take this list and concatenate with this list. You kind of have to go through the first list and then find that last point, and then you start adding the second list to it, and you're iterating through that second list in a sense too. But probably not in this case because the compiler can optimize and just point the reference to the list in that list. But still, it still has to iterate through that first list to find out where to add it when you think of it, because a list is basically item and a pointer to the next node. Don't worry about it if this seems complicated, but probably not for you. All right. So how do you add something to the beginning of a list? It looks like the element followed by a colon and then the list. So now it's taking this element and putting it in the beginning of this list. It's really fast because you have a pointer to the beginning, a reference to the beginning of the list. So you just shove it in there, and then you change what that first element is pointing to for the next item, and that's it. You're done. The rest of the list stays exactly the same. So that's why it's so fast. This will work for a list of words too, like this. Hello world. All right, I think that's ah. Oh, it's saying here how basically everything is. So if you prepend something, if you try to do one empty list, now you have a list with one item, right? But let's make this 3 actually. So here's 3 and empty list. So it's basically saying put this element 3 into this empty list. And now I'm going to say take 2 and put that in the beginning of that list, right? See how I made that into parentheses to make it easier to see? So this part returns the list 3, the list this thing, and then now we're going to put 2 in it, so we get 2 and 3. But in this case, we don't really need the parentheses. And then we can do this. So it's just saying that 1, 2, 3 is the same as 1, 2, 3. And internally, this is really what's going on. Here it's saying that an empty list is different than a list containing the empty list or a list containing 3 empty lists. They're all different things. They're not equal to each other. Hopefully that makes sense too. If you want to get an element out of a list by index, use bang bang. Indices start at 0. So let's say we have this list. Bang bang 0. Oh, I guess I can't do that. There we go. So it's first going to do this because it's all in a parentheses. So this gives us the list 1, 2, 3, and then we get the 0th element. This is the same thing as saying 1, 2, 3, 0. So it gets, this is the 0th element, the 1, this is the first element, this is the 2, and the third element is the 3, but the index is 0, 1, 2. So if we want the 3, we type in 2. And if we type in 3, it's probably going to give us an error. Lists can be compared if the stuff they contain can be compared. So lists of numbers can be compared. It basically checks if the first, it's going to do like the first index for both lists and the second and the third and keep going on. So it's going to say, is 3 greater than 2? Here it's true, so it returns. Is 3 greater than 2? Yes. Is 3 greater than 3? No. So it's going to do the next one. Is 4 greater than 4? No. And then 2, since it's greater than nothing, I guess, by default, then it says true. Let's try the other way. 3, 4 is greater than 3, 4, 2. And this is false because the empty element is not greater than this. I guess maybe you can think of the empty element as 0. Here, oh, here's my phone. I have this guy friend from a long time ago, and like, It's just so funny, like if you follow social networks and everything, there's like this whole thing they talk about the male loneliness epidemic. And a lot of people talk about it like whatever, there's a lot to be said around it. But one thing that's come out of it is like guys just don't really know how to talk about their feelings, so they often feel lonely. And usually they can only talk about it with like a romantic interest, like their partner or something like that. Which is funny because if you talk to a random guy and you start talking about their feelings, they'll be like, "Oh, I think I'm going out with you, or I must like you." It's like this weird thing. So, anyway, when I talk to him, it's funny because I'll be like, "How are you? How are things going?" And I'll get this one line response, "I'm doing good" or whatever. And then like, he might think to ask me how I'm doing. And then I write like this, this book. Um and but if I ask about like something technical or like I don't know, you know what I mean, right? Like about a video game, it'll be like here's here's like so much stuff. Anyway, random ADHD moment thinking about stuff because literally I just got a message. And it's always like so short. It's always so short. It's always so short if it's about feelings. Guys, why can't you talk about feelings? All right, so we got head here. So if we take the head of a list, we get the first element 3 out of 3, 4. If we take it out of a list of words, we get that back. And if we gave it a list of lists, here's 2 lists within this list, we get the first list back, which is the empty list. Because other guys beat us up if we do. But here's the thing, right? I guess it's like you learn that. But what if you're talking to someone who you don't think is going to beat you up? Is it just like that internalized? But yeah, I mean, I don't know. Tail will so head always returns the element type. So if you have an element of strings, head the return value is going to be a string. If your list is a list of lists, the element type is going to be a list. You saw we saw a list. Um, so here, head of a list of numbers, it's always going to be a number. Now, tail is basically returning you the list without the head, right? So if I gave 3 comma 4, I only get 4. And but the thing to notice is tail is always going to return a list, right? So if I gave it 1, 3, 4, I'm going to get 3, 4. If I call tail on hello world, I'm going to get a list. I'm going to get a list back of just world. If I call tail on an empty list, it's an error because I can't return the rest of a empty list. Um so there you go. Tail is a fast function. Yes, car and cutter. Um like literally boys who express feelings are F words and get smeared. I got bullied a lot when I was a kid in school. I was called the R word a lot, and I think it's because I'm autistic and it just takes so much time for me to process, especially when I was younger. I didn't have like these trauma responses yet and, learn how to read signs. And I just took a long time to react to social signals, and they just thought I was so slow and so stupid. So that was really hard. So here we have tail, and tail is fast because it's a little bit like head. It just has to look in the beginning and return you the list without the head. It doesn't have to go through the whole thing. However, last is slow because it has to go through the whole list and tell you the last element of a list. Last is going to first have to look at one, two, it's not keeping track of them, but it's just going one, two, and it only waits until it gets to the end where it's like, oh, there's no more here. Then it returns that value. I love this picture. Init is basically everything but last. I don't use this like pretty much ever, but head and tail often matter. I guess there's sometimes when you want to, depending on how you insert stuff, maybe just get everything up front except the last element, but it just feels like you're creating a very inefficient data structure. So here's the head, and here's the tail, and here's last, and here's init. What it's not really showing you is that head is always going to be an element, whereas tail is always going to be a list. I guess it tries to show you that. And notice init's always going to be a list also. Okay, head of an empty list. We kind of these things don't work. We looked at length already, so nothing special there. Null checks if a list is empty. Use this function instead of xs is equal to empty list. It's kind of funny, it doesn't tell you why, but I guess it's clearer. So it's like basically saying null question mark, right? Is this a null list? No, it's not. But what if I call, can I just do tail? No. No, tail. No, because that's going to return 2 and 3, right? But I can call tail again. Now I just have the 3, but it's still false. If I call tail once more, it's true because it's just going to be an empty list. All right. So if these are linked lists, length is ON. Right. It has to go through, like in Lisp. They should call that out. Yeah. They kind of did call it out a little bit when they said don't use whatever. What was it? Don't use length? No. Oh, don't use concatenate over on long strings. But you're right. This isn't a super specific like technical book, which is why I would have rather used the other book, but I just can't. Yeah, what can I do? I don't think there's much better than this. Um Null, reverse, same thing. Take. Okay, this is important. Take is used all the time because of lazy evaluation in Haskell, which means that it can be an infinite list or infinite series of some sort. And so if you ever try to evaluate it, it could like go on forever. So instead, you need to basically say, only give me this many of this perhaps infinite thing. So we can say, just take one element out of this list, then I get one. Give me two elements, then I get two, right? So notice that we're giving it an integer, which is the parameter, how many things do we want? Then we get a list of whatever type A elements, right? And it's going to return us a list of A elements. So we always get back a list. This is what that's telling us. And in case, these numbers are confusing you, Take 2 will return the 2 first ones. And take 0, I assume, would give you the empty list. And take 10 just gives you the full list since it's 4th head. Oh my god, I gotta sneeze. Woo! Why did I get... I feel like I just got like like my nose just got congested all of a sudden for no reason. All right, so drop is the same way, except it just drops basically whatever you would have taken, it drops it, right? So drop 1 from 10, 11, 10, 11, 12 is going to drop the 10. And drop 10 is just going to drop all of them because it's going to take 3 and it's like, well, they're all gone. Maximum takes a list of stuff that can be put into some kind of order and returns the biggest element. So remember we had max. And it tells you, you give it 2 items and it tells you which one's bigger. But max doesn't take a list. It doesn't work. It's saying there's nothing here. There's no max that will like actually take a list of integers and return a list of integers or something. So instead, there's a function called maximum that does this, and it finds the largest whatever element in a list. I'm guessing it's going to be an ordinal. Yeah, ord. So it's saying there's A is an ordinal, and we give it foldable T. It's a list of ordinals, I think that means, and then it returns you an ordinal, so it doesn't return you a list. So minimum does the same thing, sum does whatever, you know, it sums up all the elements. 6, right? Product will basically multiply all of them. Let's write a version of product ourselves, just to make sure we know how to code. So we'll do product, and we give it a list. Oh, it's ordered, right. Thank you for reminding me. Well, correcting me. I'm so used to Elixir here. We do if null xs. Maybe I shouldn't do this. Maybe I shouldn't do this now. If it's null, then I guess we return 0. Then we get the first. I actually don't know how to pull a number out. Maybe I'll do this later once we learn how to put variables in here. Oh, damn it. I guess I can't. All right. I forgot all my syntax. Element takes stuff out of it. For element true. Is that right? Oh, no, it's saying is for an element of this list. Is 10 an element of this list? Okay. Now we can make ranges. 1 to 10. This makes a range of numbers. We can make a range of letters too. That's good. We can have a step function between them. So 1, 3, 10. Oh no, 1, 3, 11. Okay, so that made a range up to 11. We can even make it 12. It just won't include it. We cannot give it, yeah, it doesn't work that way. It just, you give it two numbers and it's going to just add the difference up until this limit. You can also go backwards. You can also go backwards. Oh, I guess you probably have to give it a number. There we go. Okay, so it works the same way, except going backwards, you need to at least give the step. It doesn't assume it's going through 1. Yeah, it just says that here. Watch out when using floating point numbers and ranges. They do funny things. You can make infinite lists by not just specifying an upper limit. So if I do take 1 out of this list that has no upper limit, it's just going to give me 1. But I can say give me 100 and it gives, okay, that's cool. Producing infinite lists, you can make a cycle. I see. So cycle will just make a cycle of 1 and 2s, but then I should call take on it. And I get 100 1s and 2s. Repeat means there's no cycle, it's just one element. Use replicate function if you want some numbers of the same element in a list. Replicate 3 times the number 10. All right, so now we have list comprehensions. A to B is syntactic sugar for enum from to AB. I'll have to look at that function. So here, these list comprehensions are just generating lists. We're saying if we have X is a list of numbers, and then what do we actually want to return? X. So it's like a for loop where we have 1 to 10, and then we're making a list where we insert that element X into it, because that's how I think of it. So we have 1 through 10, or we can do double me X, and that was the function we wrote earlier where it doubles it. So we have 2, 4, 6, 8. Yeah. Now let's add a condition so we can have a predicate to the comprehension. Predicates go after the binding part. So this is, I guess we should look here. There's a binding part. Okay, it doesn't really say, but from them by a comma. So here it comes in afterwards, and then we have the predicate. So this is saying generate a list 1 through 10, but only if x times 2, this x times 2 is greater than 12. So that means it will skip up until 6. So it'll be 6 through 10, right? And then it's going to return the times 2. So it's going to start with 12 and go up to 20 because it's 6, 7, 8, 9, 10. All right, let's write that. So I guess I still have to kind of think of it in two steps. 1 through 10. I want to generate 1 through 10, but I only want it if double me x is greater than or equal to, I think it was 12, right? And I want to show the double me x. There we go. What if we wanted all numbers from 50 to 100 whose remainder when divided with the number 7 is 3? So we want, what is it, numbers 50 to 100. So let's do x. This is the binding part. Thanks. 50 through 100 they said, but only if x divided by has some remainder. What was it? Whose remainder when divided by the number 7 is equal to 3. And we just want x. Well, all numbers. Yeah. There we go. Do we get the right answer? Yep. All right. Note that weeding out lists by predicates is also called filtering. We took a list of numbers and we filtered them by the predicate. For another example, let's say we want a comprehension that replaces each odd number greater than 10 with bang and each odd number that is less than 10 with boom. Okay. So what numbers do we have? Each odd number greater than 10 with bang. Wait, so when do we stop? Oh, it's a function. Let me write it out literally first. Greater than 10. So we can do 1 through 20, right? And we want replaces each odd number with 10 and oh, I see. We just throw it out. So we can just say we only want odd numbers. Right? So for now, what this is giving us is all just odd numbers. And first we can check if it's greater than 10, then we can do it. If x is greater than 10, then return bang. Else, oh, we can't do that. If it's greater than 10, return bang, else we return boom. So here's all the booms, and then this is 1, 3, 5, 7, 9, and 11. We return a bang. I think that's right. Okay, so now we're going to turn this to a function. Boom bang is, and we give it a list of x's. And instead of 1 to 20, we just pass in the x's. And there we have it. I think that's right. Load first. Boom bang. That makes sense because they're all less than. But then we make it 11 and it returns us the bang. 1, 3, 5, 7, 9, 11. Perfect. So the only difference here, oh, okay, they reversed this. I see. So they reversed this, but then they, this is reversed. And there's a function odd. Edit your current file. Oh, okay. How do I, um, what's the environment variable for the editor? All right. Let's break it. See what happens. Failed, no modules. Oops. Nice. Perfect. Thanks. That's so good to know. um right. So they give an example. Oh, it's not here anymore. Boom bang 7 to 13. Boom boom bang bang, boom boom bang bang. Perfect. We can include several predicates if we wanted all numbers from 1 to 20 that are not 13, 15, or 19. We can do this. Well, I'm not going to type that because that's a little annoying. Can't believe I've been streaming for 2 hours already. I guess I was like blabbing a lot in the beginning. Now, sorry. Not only can we have multiple predicates in a list comprehension, but we can also draw from several lists. All right, so cool. Here we're going to pass in 2 lists. Let's take a look at that. Um, right, so we have 2 lists now. And if we basically say we want the value to be the addition of them, we can do like x plus y, and then it'll do 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7, then it goes to 2 plus 4 is 6, then it'll do 2 plus 5 is 7, then it'll do 2 plus 6 is 8. So it basically does, it iterates, it has a nested for loop inside of it. Wait, just use ed? Isn't ed the terrible editor that I don't know how to use? What, I don't understand what you're saying. What if we wanted all possible products that are more than 50? So we want to multiply them, but we want to know x times, we want to filter this by doing x times y is greater than 50, right? They're giving a list here. I don't know. Let's they're giving a list 2, 5, 10, and 8, 10, 11, 55, 80, 100, 110. Yep. Yeah, I have used ed before, but I try to get out of it as soon as I can. All right. This is a funny one. We get nouns, we get adjectives, and then we're just combining them together. All right. So it's just giving you all the permutations of list 1 and 2 um, by concatenating them together, which we can kind of show just by, well, all right. Probably we can just, ow. Probably we can show that just by doing this, right? No? Oh, plus plus. So it's showing we're taking 1 and 4, 1 and 5, 1 and 6, 2 and 4, 2, 5. So it's the same thing with the nouns and adjectives, except theirs is funnier. Let's write our version of length. How do they do it? They return a 1 whenever there's an element, and then they call sum to it. Uh, so we take in a list. We're going to use a list comprehension, and we are going to return a 1 whenever there's an element. We're not going to use x, so we can just make it an underscore. And then this is going to return us a list of 1, 1, 1, 1 for each element inside of x. And then we call sum on it. And then just fix the word there. There we go. 9, because strings are lists. Yeah, the underscore in many languages, like Elixir, Just means we don't need to keep track of that pattern matching. Um, so otherwise, I guess the compiler would probably be like, hey, you got this variable and like you're not using it. Because strings are lists, yeah, I think we did that. Here's a function that takes a string and removes everything except uppercase letters from it. What's it doing here? It's taking a character and is checking that it's filtering for only things that are in A through Z. Let's try to write that. Only upper, and we have well, I guess we have characters, right? Characters from but we want to make sure that C is an element of A through Z. I think that's the code. Only upper. It's going to filter out only if it's an element. We'll return it. Yeah, I think that's right. Yeah. Okay, that seems to work. Is that the same thing? ST. I guess that's string. C. Yeah, same thing. The predicate does all the work. Nested list comprehensions are also possible if you're operating on lists that contain lists. A list contains several lists of numbers. Let's remove all odd numbers without flattening the list. So we have XXS, which is a list of lists. It's a list of a list. It's a list of lists of numbers. All right, let's see if we can do it. What does it want us to do? Only remove all odd numbers. Let me just copy this so that we can use it as a test case. Is it only, we only want the odd numbers? Remove all odd numbers. Is it XS? That's not what I want at all. All right, so we have a list of lists of numbers. And the first thing we're going to do is just turn it into a list of numbers by using a list comprehension. Right? Doesn't this just turn it to a list of numbers? So this would be the list of numbers. But in this list of numbers, what we want to do is make another comprehension. We're going to have x's now, so we can do x from x's. right? So this is now a list, and we can even return the X. I don't know how to make this a little easier to view. Maybe it's like this is kind of nice. I don't know. It's kind of ugly. Um, Anyway, so now we're just dealing with normal X's, but we want it to be not odd, right? So we do probably even. Doesn't this work? Let's see. Remove odd. Oops. It's not happy. Oh, now it's happy? Okay. Just want to call it with this. Ah, here we go. 2468242626. So it worked. The let statement was required in an earlier version of GHCI. In standard Haskell, the let statement is only used in do blocks. So you're saying I don't need this? Ah, I was wondering why we had the let statement here. Thank you for answering that. But look, we wrote it. Um, so awesome. Did that make sense? Basically, this part just pulled out the first layer of lists, and we got the x's, and then this one got the x's and turned them into x, and then we returned x, but only if it was even. All right. Tuples. Love tuples. They're like an ordered list, but always of the same size. Um, Looks like tuples are just parentheses. Let's see. Tuples, you know how many values you want, and its type depends on how many components it has and the type of components. They are denoted with parentheses, and their components are separated by commas. I see. So if we wanted like points, like XY points, you could do this, but then it'd be really weird because you could have someone could type in like a list of 3 elements. Whereas if it's a tuple, they all need to be the same because a tuple of 2 elements, I guess, of numbers is a type, and all the other ones are going to have to be that way. So if you use this guy who has a 3 element one, um, this is going to give you an error because this is not the same as the others, right? Yeah. Um, but we turn this to this and we're happy again. And I think like this is okay, right? If they're all the same. Yeah. Like they don't have to be homogeneous within the tuple, but each list element needs to be the same. So they all have to be the same shape. FST first returns the first element in a tuple. Huh? Oh, what? What happened? Wait a minute. Can tuples only be 2 values? Oh, tuples are always 2 elements? No, you can have, it's just that this one only takes in, oh, I see. Got it. It only takes in a pair, and second only takes in a pair. Okay. Here, note these functions only operate only on pairs. They won't work on triples, four tuples, or five tuples. Got it. Sometimes you have to read ahead to know what you're doing. A cool function that produces a list of pairs, zip. It takes two lists and then zips them together into one list by joining the matching elements into pairs. It's a really simple function, but it has loads of uses. It's especially useful for when you want to combine two lists in a way or traverse two lists simultaneously. Here's a demonstration. So we take zip one. Here, let's just copy this. So this is making a list and it's turning it into tuple, a pair, by taking 1 and 5, 2 and 5, 3 and 5, so forth. Yeah. Okay. How does this work if this is like a larger list? Okay, so it's going to be limited by the smaller list. So this could literally be an infinite list. Yeah. Um, so I can do A, and now we have 1A, 2B, 3C, 4D, 5E. And if I do this, now I have basically the ASCII character set. Yeah, I mean, I kind of think when you learn something, you kind of have to try to ask questions because the book's never going to tell you everything, but it's doing pretty well for my questions. Um, Notice that pairs, yeah, they can have different types just like we did here. So the two lists can be two lists of different types, but each list has to be homogeneous. What happens if it doesn't match up? That's what we just looked at. It's going to find the shorter one. I guess they say it's the longer list gets cut off, but and we can do infinite. Yeah, that's what I played around with just now. Here's a problem that combines tuples and list comprehensions. Which right triangle has integers for all sides and all sides equal to or smaller than 10 has a perimeter of 24? Equal to or smaller than 10 and has a perimeter. So we're going to have a, yeah, like we're going to have these A, B, and C's, and we're going to make all of them where we have A is bound to 1 through 10 because that's the possibility, right? B can be 1 through 10. And C can be 1 through 10. And this is kind of a long list, right? Yeah, it's kind of a long list. So we have all of these. Now we add a condition that they have to be a right angle. So we need to make sure that when we use the Pythagorean theorem on it, they fit the theorem. Okay, so we go here. And we say a squared plus b squared is equal to c squared. Nine plus 16 is equal to 25. Yeah. All right. So is that right? Ah, they made that side B isn't larger than my hypotenuse, and that side A isn't larger than side B. I guess that's like an optimization, but doesn't matter, right? That's an optimization, right? Okay, now we modify by saying we want the ones where the perimeter is equal to 24. So we edit. No, oh, I didn't copy it yet. So now we want to say A plus B plus C is what? We want the ones where the perimeter is 24. Six, 8, 10. I see. We get the permutations here. So A has to be smaller than B, and B has to be smaller than C. Oops. Oh, we have to do it the opposite way. All right, great. So there's only one answer. Awesome. Well, guys, we're done with this one. Then next time we'll go over type classes. Let me actually save this one in our file. Whoops. Right triangles, 24. We can pass 24 as x, right? right triangles perimeter x, and then we just have to change this to x. I think that's right. Okay, so at least we have that in a file. Great. Thanks everyone for hanging out while we learned some Haskell. God, I should probably I want to make these into videos so that I can put them in a Haskell playlist, but I'll have to edit out all my ramblings about injections. So if you see this, probably you're seeing it without the editing. Um, Thanks for hanging out. I hope to be streaming a little bit more often and doing more Haskell. I also have to start writing my Elixir code for Elixir Conf because I know otherwise I'm going to wait till the last minute. Thank you for helping out also, Vogish Carp. That was very helpful. You know, like some people help and they're just give way too much help, but you help just right. Thanks. All right, everyone. See you soon. Take care. Bye.